guys. Shut up! I thought I turned that off. Hey guys, what's up? Thanks for watching another episode of Make Your Table Metal. Today we are doing an intro to MIG welding video, and we're going to be using this cool little weld yourself kit that we're going to have up on the website as soon as this video goes live. The big benefit of doing something like this is when you're learning to weld, you just have to run a bunch of passes. Like, unfortunately, there's no real fun way to learn. You just have to get a bunch of reps in. The kit is going to come with everything you see here. We've got two of these little uprights that basically create a stand. Here's your log. We got this cool little axe right here. You can polish the front up, cut some little details in it with the grinder, weld it to the top, and then we also threw in 2 1/4-inch caps so you can cap the end and make it look like an actual piece of wood. Really from here, let's go through some of the basics of MIG welding. I want to go over the most popular process in welding, which is, gas shielded metal arc welding, or MIG as most people call it. Basically, you're going to have some sort of power supply, a wire feeder, and a gun. The basics of MIG welding are a continuously feeding electrode, being this wire, with an inert shielding gas that basically is going to make an invisible shield around your weld puddle that oxygen cannot penetrate, is the idea. Because as you heat this up, if you remember from chemistry, chemical reactions start happening a lot faster. And what the air is trying to do with your weld puddle is oxidize or rust it. The oxygen is trying to bond with this hot metal pool that you've created, and if you let it get in there, it's going to create little pinholes and porosity, and you're basically going to have a crappy weld. So in order to keep that from happening, you run a continuous field of gas around your electrode. And how that works is right here, you have your diffuser, which has all these little holes in it right here, and this is where the gas comes out. And then you have your shield. If you remember from my flux core video, I threw this on the ground because you don't need it for flux core, because it has its own shielding material in the flux. This, on the other hand, relies on the gas, so you're going to need to put this shield back on there. And this will create a nice little cone of gas that comes out and envelops the weld area and keeps it from getting porosity. On to the machine. The basics you have here are your filler metal, which you want to look for a 70 series. Let me show you right up here. If you look at this, E70S-6, that means this is a 7 series wire, meaning 4 1/4-inch welds will support, 70,000 KSI of strength. This is the industry standard for wire, and what a lot of structural prints are based off of is a 70 series wire. The most popular stick welding rod is a ER7018. Once again, it's a 70 series wire. A lot of the flux core wires you weld with for structural applications are also 70 series wire. You get into aluminum and some of the more exotic stuff, then you get into like 30, 40, 50 series. But we're not going there. We're keeping it easy. They call these guys MIG monkeys for a reason, because pretty much if somebody else sets up this machine for you, you can run it and become a welder in about a day. This cable, the positive electrode, is connected directly up here into your drive wheels, which is your whip or your hot end. The negative side over here is your ground clamp, and this is what gets attached to your work or the table. This guy. Make sure that you have the polarity correct on these. If not, all you do is simply take off this lug, swap them over the other way, and hook it back up. You're not going to break it if you do it wrong. Your welds just are not going to turn out how you want them to. Now that we're done inside the case, the first thing you want to do is set up your welding gas. We use a 90-10 mix of argon and CO2. Some people use pure CO2, and you can also use pure argon if you get into the pulse or spray transfer functions. But for you guys, pure CO2 or a 90-10, 75-25 mix is all you're going to need to do a regular short circuit MIG, which is what we're going to set up for you guys here. So make sure your gas is on, and I like to be about 30 CFM. This is your supply side, how much is in the bottle, and this is your feed side, how much is going to your welder. Front of the machine, we got our wire, we got our polarity, and we got our gas going, right? So the next thing we got to do is set our voltage and wire speed. And this is what separates the boys from the men in welding. Anybody can pull the trigger and fill up some metal with a properly set up MIG welder. It takes some skill and some practice and educating yourself to learn how to set up these 2 knobs on the front of the machine. So So today we're gonna spend some time and just experiment and play with this thing and see what happens. And I'll show you guys kind of some troubleshooting, what to look for, what you don't want to see, and what to do over here on the machine if you want to correct basically what you're seeing and you're not happy with it. Okay, we're here at the front of the machine. There's really only two controls. You have your voltage or heat setting. Mine is adjustable to 1 decimal point, and then you have your wire feed, wire speed over here. This one can run, I don't know, definitely up to 500-600 inches a minute. Your machine may not run that fast, but you don't need it to get started. What I would recommend is anybody MIG welding, start with a 220 volt machine. You can get mildly acceptable welds using this process with a 110 volt machine. You're gonna have a lot better luck with flux core. So if you only have 110 volts of power, I really encourage you to go check out my other flux core video and maybe consider going that direction first until you get some more power set up. Every single machine has some version of this weld chart right here. It's either gonna be on a front panel or underneath this side panel back here where we loaded the wire up. But what you're gonna look for is the MIG or GMAW welding chart. We have pulse up front, don't get confused like me, and get this MIG chart going right here. So what we're looking for is our shielding, well, first our material. So we got steel, and then we're looking for our shielding gas. Our closest welding mix, I'm not running 100% CO2, I'm actually running a 90-10, but we're just trying to get close here. And this is where you guys start seeing the value in knowing how to set your own machine up, because it's not totally clear. So we're gonna go down this row and look for our material thickness. The tube we're welding today is 1/8 inch thick material, and we are an 035 wire. We're actually an 030 wire. We're gonna use this setting to start. So it shows 18 volts and 260 inches a minute, right? So we're gonna set up this machine right here to 18 volts and 260 inches a minute. This is gonna be a good baseline. Like I said, it's not the exact same wire diameter, it's not the exact same gas mixture, but this will get us close and get us started. So your machine may not have the exact same readout as mine does. If it says 1, 2, 3, 4, 5 for your heat setting, and you have like 1 to 100 on your wire speed, that's fine. Just follow the manual and get it set up for the closest thing you can find on there. All right, once you get there, let's head to the table and get to welding this sucker. Let's do this. Now we're back at the table. We got our gun, we got our ground clamp hooked up. If you don't have a metal table, you better put this directly on your work here. If you do have a metal table, just put it on the table. Then you're gonna need some safety stuff. I really recommend having some gloves. Wear your safety glasses. This stuff's bright. Have yourself a welding hood. Auto tint's a little bit easier, but you don't need it. I also have sitting on my exact same bench a fixed shade lens with a gold shield in it. This is the clearest, brightest, best welding hood you can get as far as vision, but it's not auto tint. So some things I really like to use this. But for MIG, you're just doing production work. You're just trying to crank some stuff out, so an auto tint is where it's at. Then you're also gonna want some pliers, and I would definitely recommend, if you're getting started, a whole grip full of tips. Because what you're trying to do is keep the tightest arc gap possible while you're welding without dipping the tip. If you dip the tip, the thing's gonna crunch up, you're gonna have a hard time, and you're gonna need to replace it. So it's one of the top things that new welders burn through. So just plan for it, have them on the shelf. Let's make sure we're running our wire and we can hear the gas running. All good signs. Grounded, we got gas, we got our safety stuff. Let's start tacking this thing together. First part of this kit is this cool little stand we have right here. This is what's gonna hold our log, so to speak, and really just kind of hold it square. And nail it. Square it up. Go to town. All right, then you're gonna want to pick the perfect orientation for this log here. You know, how do we want it to sit? How do we want these cuts to look? It's all up to you guys. So I need to get this to sit flat, back on the table again. Basically, this thing was sitting three-legged. I had one of the legs floating, and since it's just tacked and we haven't welded it up yet, it's still a little bit flexible. So I basically just got this thing back sitting flat on the table and just beat it down until it's flat again. This is where we get to start having a little bit of fun. I wouldn't recommend starting right here on the top because that's probably what's going to show the most. So when you're running your first passes, tilt this thing around and work on it upside down, and we can start practicing a little bit down here where it's not going to show so much. All right, so we're going to start with our factory settings, and one of the things I want you to remember is ABC, always be comfortable. I got a freaking stool back here, guys. Then you want to get a spot where you can just rest your elbows real easy, or maybe rest your hand and somewhere where it'll slide really nice. You're going to be working this back and forth across this tube as we go. Okay, the old saying goes, drag, slag, and push gas. This is a gas shielded process, so we're going to want to be pushing it as we go. You can just rest this shield right on your material if you want, or you can choose to float it over the top. But basically what you're trying to do is maintain this kind of a 1/4 inch to 3/16 of stick out between the end of your tip and the material. So from here, guys, pretty much just grip it and rip it. All right, you guys can see here, this is actually sitting pretty tall and lumpy. I just ran basically what's called a stringer bead. I didn't weave too much. We just kind of pushed this electrode across the metal. So let me show you guys a basic weave next. The weld got about 2.5 times wider, and it's still sitting pretty high up here, pretty lumpy. So to fix lumpiness, you can either do two things. You can turn down your wire and have less wire get piled in there, or you can turn up your voltage and create more heat and make that wire wet out and sit flatter in there. I generally like to err on the side of more heat, and because I'm trying to get faster and faster here in my shop. I want more heat, more wire, so I can get more weld out the door and get more checks back in the mail. You know what I mean? So let's go back to the machine and we will start pressing on this heat a little bit. We're at 18 volts right now. Generally it's good practice to move about a 1/2 volt a time, but I'm gonna just push it a whole volt and we'll go to 19 and keep our wire speed the same. Let's go back and see what this does. That's starting to sit a little bit flatter. If you kind of notice from our first weld, so we're moving in the right direction. Now let me show you guys a weave with the same settings. We're really starting to get closer on the settings here. I personally like to run weaves most of the time because the stuff sits a little flatter. You can tie in your edges a little better. But you see, by just stepping our heat up an extra volt, this whole weave sits a whole lot flatter and is a whole lot more even. So same welder, same material, same gas, same machine, totally different results off the welder, okay? So if you're not having the results you want right away, you know, go back to that machine and mess with it a little bit more. We're gonna keep going all the way outside of parameters just to show you guys what's possible. So let's go over there and step up to a way hotter, way faster setting and just see what happens over here, all right? I'm gonna go all the way up to 24 and let's step this wire speed up to 480 and see what that does. So we are like twice as hot, twice as fast. Well, twice as much wire, not quite twice as hot, but let's see what happens. That sucker was cooking, man. We really had to pick up our travel speed, and just this stringer itself is probably 1.5 times, maybe 2 times as wide as these other colder ones were. So let's go ahead and bump this into a weave, and let's see how much we can wash this weld puddle around with this higher heat and higher wire setting. Woo! This thing is just glowing red hot. See See how much heat we dumped into that thing? You guys have seen regular, you guys have seen too hot, so now let's turn everything down and I'll show you too cold and what kind of problems and things to listen for that are signs that you're too cold. Because what happens with a lot of new welders is you don't quite have your travel speed down, you don't quite have the wiggle down, so you start burning through the metal and you think it's the settings on the machine and not you. I'm not saying it's always gonna be you, but let's just say the machine is usually wrong if you're having trouble. Ta-da machine! All right, so we did regular, we did hot. Now let's do cold. Originally we were at 18 volts, right? And 260 inches a minute on the wire speed. So let's keep our wire speed the same. Let's try and keep this constant and our heat the variable. And let's go down a volt instead of up a volt. Now we're at 17, wire speed's the same. Let's go see what happens. See this glob on the end right here? It has a really hard time starting on that glob. So do yourself a favor, nip that off with a fresh tip. Not that bad actually. I thought this was gonna be a lot worse and a lot lumpier. It laid down pretty good. It's just sitting tall, so I know it's not penetrated very deep. If you see your weld sitting mostly on top of the metal, that means your weld is mostly on top of the metal, and you want it in the metal, holding both of them together, not sitting on top like glue or like a carpentry project, right? The other thing I want you guys to pay attention to, you notice when we got hot, that weld got really, really wide, and now we got cold and it got really, really narrow. So if you're doing really precision stuff, you may want to be a little bit colder. If it's not, you know, a structural component, once again, you can be a little bit colder. You just need it to stick together. There's lots of situations where you just need to fill something up. So keep that in mind. If you need a bigger, fatter weld, more heat. If you need more control, a little tighter weld, less heat. Now let's do a weave with the exact same settings. Not too shabby, but still sitting lumpy. See how tall it is? One of the biggest weaknesses of MIG is called cold lap or cold roll. The metal isn't actually penetrating inside, it's just rolling up over the apparent metal, and you're not really getting very good fusion, and the stuff's just not tied together like it needs to be. A lot of guys would be fine with this. I just know better. So let's go even colder, because this thing is even sounding pretty good, and sound is definitely something that'll help you diagnose a good or bad weld, but it's not the end-all be-all. Let's turn this down some more and see if we can get it to start acting up and sputtering and making the sounds that'll tell you got a bigger problem, all right? To the dials! All right, exact same wire speed. Let's turn this down. Let's get to 14.5 volts and see what kind of mess we can make there. We're gonna run a stringer at this cold setting, and then we'll run a weave. All right, that was painful, but you guys could hear that. It was sputtering, it sounded sick, it sounded bad. Let's take a look. It is bad. This is like classic hammered dog welding. Zero penetration. This has gone nowhere into that metal and is gonna break probably just by breathing on it too hard. If anything like that happens to you, stop, go back to the machine, check your polarity, check your gas. It should not look like that. Let's get us to 15.5 volts here. We'll step up one and see what that does for us, all right? Let's run a stringer at this setting. All right, we could get it to like kind of run, but basically what I was doing is keeping this gap ridiculously short. The shorter your gap, the hotter your weld is gonna run. The longer your gap, the colder your weld is gonna be. So I was basically getting out of range on my stick out just to get the voltage high enough to do anything with this weld puddle. We got enough volts where it's all beaded together, but it is literally sitting on top. There is no penetration. Do not send anything out the door welded like this. Don't even use it yourself. Pretty much from here, what you guys need to do is run a bunch of passes and start figuring out kind of the different ways you can travel. You can do weaves. A lot of guys like to do cursive E's in their weave. You can do a zigzag. I like to kind of think of it as like little small smiley faces. You know, there's no mistakes, just happy accidents in welding. You can turn this thing up on its end and run vertical up. You can run vertical down. You could, even if you wanted to get really crazy, run this thing around and around and around like you were pipe welding. Really the idea here is you want to run a bunch of passes all on the same thing continuously and get yourself some reps, right? So I'm just going to go to my happy place and kind of start welding this thing out, all right? I'm getting bored of just running passes here, so I'm going to actually start putting a couple little tree limbs in here. We're going to just build up a big circle of weld here, and probably another one back here, and at the end we'll just grind them off and it'll look like a little branch that we cut off. So if you get bored, just start playing with it. One thing I'm doing is I want to actually build up the metal here. I don't want this to sit down. We're trying to build it up. So I'm going to run a really long stick out. Instead of going back to my machine and turning the voltage down, I'm just going to run a really long stick out here, and that'll drop the voltage at the weld point and let me build up metal instead of, you know, pushing it down into the metal. And if you guys get really bored, you can turn this thing up on end and start running some verts. Code-wise, you want to be traveling vertical up. That's the strongest weld you can do. But the prettiest one often is vertical down. Oh yeah. Sorry, I just kind of lost track of where I was. But looks pretty nice. Now I'll show you a vertical up. It looks a lot different, but it's a lot stronger of a weld. So this one, if you guys can see it, has really nice tight V pattern, but it sits a little bit taller. It looks like it's sitting up on top, but believe it or not, this is actually penetrated further than this downhill flatter weld. This is just another one of those counterintuitive things about welding, that if I cut this in half and bent it and showed you guys how much it had penetrated, this weld right here, the vertical up, would have penetrated like 1.5 to 2 times further into the apparent metal and just basically be grabbing it harder than this over the top. Don't always rely on the visual inspection for the weld. Sometimes you have to get into the metallurgy and get a deeper understanding that it's not always the prettier weld that is the better one. Let's finish this up and get onto this hatchet. Alright, we got this sucker welded out. Now it's time to put on the finishing touches. Pretty much, we got the hatchet, and we need a grinder with a wire wheel and a flap wheel. So let's work on this hatchet first. Come on. Last thing I'm going to do is weld this to the log to make it look like it was just kind of put there and left halfway through the job. But if you put it like this, it's going to look like it's sitting on top. So I always like to burn a little flat edge into this blade, and then it looks like it's inside of the wood, and just kind of a cool little detail. And a little ticky-tacky. There you go, Dunsky. There's really no right or wrong way to do this. You honestly don't even need to buy this kit from our website, but we have all the parts if you want. You could really just get a pipe and a chunk of metal and do this with a cutting wheel. It doesn't really take a lot of complicated tools, but hopefully you guys get out in the shop, run some passes, mess up that machine, learn how to fix it, because that's what sets the bad welders apart from the good ones. It's not that you never make any mistakes, it's that you know how to fix every single mistake you come across. So happy making, guys. Subscribe, follow along, check us out on our website, makertable.com, maker.table on Instagram. We really want to help you guys make more cool stuff in your shop. Later.